Welcome. We're looking at factoring polynomials where the coefficient of the first term is not 1. That's going to add a level of complexity to this. So let's take a look at this first example here. You see that the result has a 2x and an x. That is the only way to multiply to get 2x squared, so it makes sense. At the end of it, we have 5 times 2 to make 10. That makes sense too. It could have been 10 and 1, but 5 and 2 is the correct answer here. Well, the issue with this is that when we learned how to do this without a coefficient, or a coefficient only of 1 for x squared, then it was very easy to get the b here, but right now we can't do that by adding these two like we used to. So what that 9 comes from is a combination of the 2x times the 2 here, which is 4x, and this 5x, and that's how you get the 9x. How do we find out that it's 5 and 2 there? All right, what we do, instead of like 10 and 1, and on which side does the 2 go? So there are a number of methods for doing this. All right, we're going to start with one of these where let's start with doing this. We still need to do the thing where we have to find the two numbers that multiply, or two numbers that will add to 9 and multiply to 20, not 10. So on the top here, when we multiply to get something, the number we have to multiply to is 2 times the 10. So I'm going to put a 20 here, and a reminder that that's a times c. And the number we want to add to is the 9, the b that's here. So this is c and this is a, just as a reminder. And to do that, the factors of 20 are 20 and 1, 10 and 2, and 5 and 4, and those are the two that would also add up to 9. So we can put a 5 and a 4 here. Now the question is, what do we do with it? Pretty much every method requires that. Well, there are a couple of ways to look at it. The classic way, which in some ways is actually the one that makes the most sense, is to take these two numbers, put the 2x squared, take the 9x and split it up as these two. I'll do plus 5x plus 4x, and then put the plus 10. So really all we're doing is taking these two, or taking the 9x and just writing it in a different form. But doing that allows us now to use the grouping method to basically break it down. So we're going to do common factoring 3 times. So if I split it in half, I look at these first two, and I see that it looks like I can take an x out of both of those. The 2 and the 5 don't have a common factor, but the x squared and the x do have a common factor. So I can take an x out, and I have 2x plus 5. On the other side, it does look like I can take a number out of both because the number 2 goes into both of those, but no x does. So we're going to have a 2 and an x plus 5. And then what we do is we look at the fact that x plus 5, oops, forgot to have the closing parentheses there. This 2x plus 5, oops, and I forgot to put the 2 there. Let's do that. And let me rewrite that so it's clearer. 2 goes into 4 2 times, so it's 2x and plus the 5. Good, now that looks more correct. And that actually identifies the fact that these two have to be exactly the same. So what we have is the concept of having something like x times y plus 2 times y. And if you saw that as simply by itself, you would do, oh, let's take a y out and we'd have x plus 2. So we have a common factor of y that we're taking from both of these. Well, this 2x plus 5 is essentially our y here, or a variable or something like that. We see it as like a separate entity. So I'm going to remove that as a common factor. And then the other two things 2x plus 2. They go together. This is plus because it wasn't minus. Just simple as that. There's no negative there, and we're not taking it out as a negative, which we would. If this had been a negative, we would take it out as a negative, but it's not. So not an issue. So that's it. That's the answer, 2x plus 5 and x plus 2. Before I start on the next one, let's look at an alternate method that some people like. So I am going to do this where I'm not going to rewrite it like I did in this one. That's like a really cool way of just splitting up the 9x into the two things, and it's easy to do too. Well, now let's look at the idea of setting up our parentheses already. And we know we have to have an x and we have to have an x. Now, really, one of them has to be 2x, but we don't know which one. So we're just going to put x and x. Then we do this thing over here. And we find out that it's 5 and 4. So we're going to put the plus 5 and the plus 4. And then we're going to look at the coefficient of 2. And whatever the coefficient is of the a, whatever that a is, we are going to divide by that here and here. We're going to put it under both numbers only. Now, we're going to sort of simplify it. We are going to simplify it because 4 over 2 here, that is definitely a 2. So we simplify it and, oh, x plus 2. Well, there's one of our answers already. There's the x plus 2. But the other one can't be reduced because we're sticking with only integers. Integers means not decimals, not fractions. So we can't leave it as 5 over 2. And we also can't leave it as like 2.5. So what we can do is this format, x plus 5 over 2 is the same as if you took the 2 and put it in front. So that what we get is 2x plus 5. We get the same exact answer. So we get 2x plus 5 and x plus 2, 2x plus 5 and x plus 2. Well, we got the answer either way. Doesn't matter which one you use, both of them are correct, or both ways. And there's other ways to look at doing it too. There's a variation to it of the second one that's pretty easy to do with, but I'm not going to do that one now. We'll instead look at this problem. And I'm going to do this next one. If you want to and think you're good enough at it already, pause the video, try to do it yourself, and then come back to it, and then look at what I'm doing and see whether or not you've gotten it correct also. I'm going to make the x, and I'm going to do the a times c here and the b here. So 6 times 7 is 42, and 23 is here. So what we're now looking at is finding the two numbers that work to make that. I'm going to go over, I don't know where I'll do for space. I guess I'll take the 42 here. And the factors of 42, I'm just going to write them down until I find two that add up to 23. Oh, right there. Okay, I could keep going and do 6 and 7 and such like that, but it's 23. If the middle term had been, say, the number 13, I would have ended up using 6 and 7. But it's not 13, it's 23. So 21 and 2 seem to work perfectly okay here. So I'm going to put 21 and I'm going to put 2. So I'm now going to do this first method. I'm going to do 6x squared, and instead of 23x, I'm going to use these two numbers, plus 21x plus 2x, and then I'm going to put the plus 7. By the way, just for your information, if I had done it as 2x plus 21x, I would still get the same answer. So if I had reversed it, I would still add up to 23x. It doesn't matter which when it goes first and which one goes second. It would make the next step different, but still correct. So it's perfectly fine to do it the other way. So now I'm going to split it in half, and I'm going to look and see what are common factors here. Well, they both have an x, so that's an easy one. And they have a 6 and a 21. 6 doesn't go into 21, but 6 is made up of 3 times 2, and 21 is made up of 3 times 7, so it looks like there's a 3. So I'll use blue for the next part because I'm going to take the 3x out. I'm going to be careful. The 3 goes into 6 twice, and the x cancels out one of those x's. 3 goes into 21 7 times, and the x cancels out. On the other side here, I'm going to have a 2x plus 7 afterwards, but look, there is nothing that goes to either of these. Nothing divides into both except the number 1. And you're allowed to. In fact, you pretty much have to do that because you need something for the second binomial. So since it's not negative, that means it's just going to be positive. And the 2x plus 7, and that's our second common factor. Now we'll take the 2x plus 7 out as a common factor, and we have the 3x and the plus 1, and that is our solution. So if you got that, you were right. Now let's see if you tried it the other method and saw whether or not you got it. By the way, if I were to just check this, we'll do it in the red. 2x times 3x is 6x squared. 2x times 1 is plus 2x. 7 times 3x is plus 21x. 7 times 1 is 7. And that looks very much like 23x. And so that confirms the check that that's correct. Okay, let's take a look at using the other method. So I'm going to set up the parentheses. And I'm going to put x and x automatically. And then I'm going to put the two numbers, 21 and 2, or 2 and 21, doesn't matter. And now I take the coefficient of the first term, the x squared term, or the a, and I'm going to divide by that a. So I'm going to divide just the number part by the 6. So what happens in this one, I'll switch to blue for it, x plus, well, 3 goes into both of these, so we get a 7 and a 3. Is it 3? Yeah, no, 7 and 2. Let me think. 3 goes into 21 7 times, 3 goes into 6 2 times. Okay, that looks much better. And then I am going to get this one, where it's going to be x plus 2 over 6 becomes 1 over 3. Neither of them can be reduced anymore. So that means for both of them, I'm going to have to take this bottom number and put it in front for both of them. And when I do that, I get 2x plus 7 and 3x plus 1. And that looks very much like the answer on the other one. So they are both correct. I already checked this, so I know that that's the correct answer. By the way, the other method that's similar over here to this last method is I would, instead of putting the 6's by dividing there, I would end up, I think I'll use just all the red here for this one, I would put it both 6x and 6x like that. And then I would put in the plus 21 and the plus 2. And then what I'd do is I would see, can I reduce inside these? In this first one, I can take a 3 out of both of these. And so I get a 3x plus 7. And in the next one, I can divide both of these by a 2, looks like. So I can get a 3x plus 1. I think I need to write those a little neater so you can clearly see them. So I'm going to do that. This 3 goes into 6 2 times, so it's 2. I need to make sure I did make it a 2. And the x and the 3, this makes a 7. 2 goes into 6 3 times with the x and a 1. I get the same answer, but it requires that I put the 6's in there, and then I divide by something, and I throw those away. Once I do that, this is like the only place in math where you throw them away, mainly because I put in 2 6's and I only need 1 6. So I end up having to throw away some combination that multiplies to 6. So this one is like a little trick one to do. Perfectly fine, great way to do it. I've used it a lot, many times, and for a long time it was my preferred way. This way is similar to it, but you're not like throwing anything away. There's no trick to it, really. I guess you could say that divide by the 6's, but it works out as long as you remember to do this part where the denominator after reducing goes over to here, or after simplifying. And the first method is a classic way to do it, which makes a lot of sense because of that middle term being split into two. Entirely your choice which way of these that you do, as long as you get the answers correct. So let's look at the two bottom examples. Okay. Again, this is a very good place to pause and come back to it, and I'll start talking again in about 3 seconds, and you can in the meantime work on these and then come back and start it again. All right, now let's take a look at this. And so I think I'll do one method on one method on the other, just for the fun of it. So on the first one here, I am going to look at 2, 15, and 25 for my A, B, and C. Okay, so 2 times 25 is 50. 15 here, I need to add to that, I need to multiply to that. So I need to think of the numbers that make up 50. So I have the 50 and 1, 25 and 2, 5 and 10, or 10 and 5, since I learned that way. Aha, it looks like that's it. 5 times 10 is 50. 5 plus 10 is 15. I'll do a 5 and a 10. So over here now, I am going to do 2x squared plus 5x plus 10x plus 25. All right, now, I have lots of room down there. I can maybe use that. I guess I will just keep going because I think this is easy to do. I'm going to split this here. And it looks like from both of these I can take out an x, but only an x. So if I do that, I have an x here, and I have a 2x plus 5. On the other one, it looks like I can divide not by x's, not by 10, but a 5 will go into both of these. So I'm going to have a 5, and that's going to make it 2x here. And on the other one, well, 25 divided by 5 is 5. Here is my common factor, 2x plus 5. And then these two get to go together here. And I will just check to see 2x times x is 2x squared. 2x times 5 is 10x. 5 times x is 5x. And 5 times 5 is 25. And these two make the 15x that was in the original. So that way I have checked it. So I can now say with confidence that this one is correct. Let's look at the next one. On this next one here, I'm going to have to do the same thing with the diamond concept. And 10 times 3 is 30. That's A times C, and multiply and get that. And then the B is 17. Okay, so the numbers that multiply to make up 30 are, well, 30 and 1, 15 and 2. Oh, okay, it looks like we don't have to do 6 and 5 and such. We can use 15 times 2. So 15 and 2. I'm going to use the other method this time. So I'm going to do x plus 15, x plus 2, and then the b, or the a rather, I'm going to divide the numbers by the a, and that gives me x plus, well, let's see, 3, no, 2, 5. That looks like 5 goes into both of these, so I get a 3 on top and a 2 on bottom. And here, 2 goes into both of these, so I get a 1 and a 5. But that means I need to take that 2 and put it here, and the 5 and put it here. So my final answer for this is going to be 2x plus 3 and 5x plus 1. And I'm going to check to see if that's right. 2x times 5x is 10x. 2x plus 1 is plus 2x. 3 times 5x is plus 15x. And 3 plus 1 is 3. And that gives me 10x plus 17x plus 3. And that's what the original one was. Bring that so you can see the whole thing on one screen. Well, we got it. Both methods, they both work for it. Let's look at when there are negatives involved. All right, so on this example, with 7x, go do this color, 7x squared minus 30x plus 8. So I'm going to multiply to negative 30 and add up to 56. So we have negative 28 and negative 2. So why 56? 56 because 7 times 8 equals 56. And we did that by just a classic thing of 56 and negative 30. But because we're going to multiply to make a positive number, they both have to be negatives. So 56 is made up of negative 56 times negative 1. And let's see, then negative 28 times negative 2. Up, and there it was. We didn't have to do 4. And let's see, 4 would work, yep, 4, 19, and other numbers. But now I can see that it's negative 28 and negative 2. So for this one, I'm going to use the splitting up method, 7x squared minus 28x minus 2x plus 8. And then I'm going to draw this, and let's take out the common factors. So I have 7 goes into both of these, and x goes into both of these. 7x, x minus 4 over here. Now lesson, if this one is negative, the third one, first part of the second half, then you must take out a negative. So it has to be a negative here. And the only number that works is 2. So it looks like it's going to be minus 2 or negative 2. So that turns these negatives cancel over here and makes it positive, and it's an x. Here, plus and minus makes it negative, and that's a 4. And good, these two are the same. So we'll take those out as a common factor and put the other two together. And I see a 7x squared and negative 8 at the end, and negative 28x here and negative 2x there. So I can confirm that that one's correct too. So you just have to think about the negatives. In this case, because this number at the end was positive, you know you're going to have 2 negatives. Right? There's no question. And that happens then with 7 times 8 and makes it positive. You have a number here that's negative on this next one. That means that one number will be negative and one will be positive, because you can't multiply to make negative 6 without having one positive and one negative. So let's do our little box thing. And think 12 times 6 is a 72, but it's a negative 72. And here there's a negative 1 in front of that, of the b. So we're going to find the things that multiply to 72 and add up to 1, but 1 has to be negative. So if I take the number 72, negative 72, well, I can have negative 72 and positive 1, or 72 and negative 1. And I can do that all day with those. So if I keep doing different numbers, I'm going to ultimately see, let's see, 8 times 9. So 8 times 9 makes 72. If I make the 8 negative, it's a positive 1. But if I do 8 and negative 9, I get a negative 1. Well, that seems to work okay. So let's do, this time I'll use that second method. And I'm going to do x and x. And I'm going to put those two numbers. Let's do plus 8 and minus 9. But I have a 12 I have to divide by. So that's going to give me x plus 8 and 12. I can reduce that by dividing both by 4 and getting 2 over 3. And here it's x minus 9 over 12. If I divide them both by 3, I get 3 over 4. So now that I've done that, they cannot reduce anymore. That means that the coefficients, the denominators have to go and become coefficients over the first term there. So I get 3x plus 2 and 4x minus 3. And then when I look at it, it's very clear the plus 2 and minus 3 makes your negative 6. But the combinations, 4x and negative 3, 3x and negative 3 makes negative 9x, and 2 times 4x makes 8x. That works out to make a negative 1x. So here we are with that one. There are 2 at the bottom, one that has a negative for the third number and one that has a positive. Go ahead and pause the video, do those, and then come on back and see if you get them right. All right, I'm going to do it now. So on the first one, let's think about what numbers we'll use. I'm going to see 7 times negative 8 is negative 56. Okay. And negative 26 for the B, and this is A times C. And now I have to think over which of the numbers here, what things are going to enable me to get that. Okay, so let's play with some numbers with 56. Well, one thing is that because this is negative and that's negative, we're going to add up to negative, but we're going to have to multiply. That means one has to be positive, one has to be negative. So that doesn't help no matter which one's negative. It doesn't add up to 26. So if I divide by 2, 56 divided by 2, we get a 28. Okay, so 28 and negative 2, well, that adds up to a 26. But if I do negative 28 and a 2, that adds up to negative 26. I can keep going with 4 and the others, and we saw this before in another problem. But now it looks like we can use these two numbers. Okay. So I'm going to do, which method? I guess I'll do both methods. I'll do this one. Let's see, where did I use that before? I used it up here, and in that case I used, with the 7 and the 8, I used the splitting up method. Here I'll use the parentheses method with just the x's in there, which means I'm going to put in the negative 28, and I'm going to put in the plus 2. And then I'm going to put the 7 underneath both with the red. I'm going to put 7 underneath both, and let's see what we can divide by. Well, on the first one, 7 goes into 28 4 times, x minus 4. In the second one, it doesn't do anything whatsoever. We have to bring the 7, and we have to bring it over here, so we get 7x plus 2. Well, let's see if that works to multiply it out. X times 7x looks like a 7x squared plus 2x minus 28x and a minus 8. And right here we see it's negative 26x. 7x squared minus 26x minus 8, that checks it. So we know we were correct. I don't need to keep all these lines here, but I am going to do my yellowing in of it. Whoops, I don't want those to disappear. So let's go like that. And there's our solution for this first one. Now the second one. 8 and 25. So I need to do A times C here. Okay, so 8 times 25 is 200, but it's positive. But we have to add to a negative 30, and that's the B. So we need the numbers that multiply to 200 that add up to negative 30, but they both have to be negative. So 201 doesn't help. Let's do 102, doesn't help. 50 and 8, well, that's not much of a help so far either. 50 times 8, okay, so 40, now I have to think, let's see, 40 into 200, gosh, I have to remember my own numbers here. If we divide, that's going to be 5, okay, that still doesn't give me 30. Okay, so 20 and 30, let's see, 30 times 30 doesn't do it. 25, gosh, I have to try to remember. And this is exactly where you think, what do we do? This is a good example for how do we figure out this? So you start taking a number when there's a whole bunch of them, like, I've got 10 and so on, 10 and 20, because there's a 0 here. Let's divide by 10. So here's 10 and 20. Well, if both of those are negative, that will add up to it. I could do others. I could do bunches of other numbers. This one has a lot of factors for it, but negative 10 and negative 20 look like they will multiply to make 200 and add to the negative 30. So if I do negative 20 and negative 10, okay, good. Let's use the other method here where we'll do the 8x squared and we'll split negative 30x up into those two separate ones. Negative 20x minus 10x, and then we'll do the plus 25. Split this in half. I can divide both of these. It looks like they both have an x in them. But the 8 and the 20, okay, 8 doesn't go into 20, but 4 goes into both of them. So 4, I'll do as if I'm taking out a 4 from both. On the other side, I look and I first see that because that's negative, it's going to have to be a negative number. And x's, they don't both have x's, but they both have 5s. They both don't have 10s, but they both have 5s. Okay, so now I have 4x, and 4 goes into 8 twice, so it's 2x minus, the x's cancel, we got a 5, minus 5 over here. 5 goes into 10 twice, so it's 2x. The plus and the minus here become a negative. We have another common factor. I'm self-satisfied here that I could see this and figure it out, even with the big numbers there, relatively big numbers. With a calculator, nothing is too big, really. Not for this. Now, let's think about that. The 2x times the negative 5 is negative 10. Negative 5 times 4 is negative 20. So there is the negative 30x. And the ending numbers multiply to make 25, and the first two of them multiply to make 8x squared. So that gives us our answer for that one. So now you see two different methods used with positive and negatives for factoring out or factoring trinomials when the coefficient in front of the x squared is not 1. It's one of the more difficult factoring procedures or what's needed, but now you have a couple ways to do it and find one you're comfortable with and get really good at it, and these will not be a problem. So thank you for watching. I hope this was helpful.